Now the problem is you have to find out the nth derivative of sine hyperbolic 2x into cos hyperbolic 4x. Here you see, here you are getting that sine hyperbolic 2x into cos hyperbolic 4x. Okay. Now here you don't have the nth derivative for directly for the sine hyperbolic 2x as well as cos hyperbolic 4x. As the product of these two you don't have the directly. First you have to write the sine hyperbolic in terms of the exponential function as well as cos hyperbolic in terms of exponential function by using the definition of the hyperbolic functions of trigonometric functions, that is sine hyperbolic x and then cos hyperbolic x. Already you know sine hyperbolic x is equal to how you are writing e to the power x minus e to the power minus x by 2, that is the sine hyperbolic x. In place of x,
Where?
it's by 2x.
Yeah.
And cos hyperbolic 4x is there. Here also already you know cos hyperbolic x you are writing as e to the power x plus e to the power minus x by 2. Replace x by 4x, will get this. And here you see in the both denominators you have 1 by 2 is there, here 1 by 2 is there. You are writing 1 by 4 outside. And then if you open the bracket here, this into this here, totally two components into two components is there. So that you are getting here totally four components you are getting here. Four you are getting. Now if you open the bracket and if you do the simplification, you will get this. Already you know a to the power m into a to the power n, you can add as a to the power m plus n. The same you are using here. E to the power 2x into e to the power 4x you are adding. E to the power 2x plus 4x you are writing. The same you are writing. Here the remaining are same in the same manner we are writing here. Okay. Now you see you have to find out the nth derivative. Now you have to
Hello?
ఇంగ్లీష్ క్లాస్ నా తెలుగా కన్నడ.
okay. Now here you see you are getting this is the value of y. After you are getting y, you have to write the nth derivative. Okay. Now already you know the nth derivative of e to the power mx is how much. First you write here d to the power n of y, that is equal to yn you are writing, because yn is the nth derivative that you are writing d to the power n into y. Already you know the y is equal to this you are writing here. Y is equal to this you are writing. Now here if you apply the linearity property, you can write this as d to the power n into e to the power 6 is d to the power n into, and here also you are writing minus n, what you are writing by using the linear property you are writing here. Okay. Now already you know e to the power mx derivative you have taken, the nth derivative you have taken. What is the nth derivative of e to the power mx? You see the previous classes there you have taken there. E to the power mx is m to the power n into e to the power mx you are writing. The value of m is equal to 6 here. If you replace m to the power n means you get 6 to the power n e to the power 6. Similarly, you are writing the remaining thing. Here m is equal to minus 2, here m is equal to 2, here m is equal to minus 6. By applying the nth derivative of e to the power mx, you are writing here, is you are writing. What is e to the power mx nth derivative means m to the power n into e to the power mx. The same you are writing here. That is nothing but the required one. And you remember here, sine hyperbolic into cos hyperbolic is there, then you have to go for the definition of the sine hyperbolic function as well as cos hyperbolic function in terms of exponential. Then you have to simplify, then you have to apply the nth derivative. Now the second one, you see the second one is here, y is equal to e to the power minus x into cos hyperbolic 5x. E to the power minus x into cos hyperbolic 5x. Okay. Okay, now here you see here you are getting here, another format. Okay. Okay. Now, just to see the second one here, you are writing e to the power minus x into cos hyperbolic 5x. You are writing here. Again, here cos hyperbolic function means you don't have directly e to the power minus x into this. You don't have. That's why here you are writing e to the power minus x into again the same cos hyperbolic function x. You are writing. How you are writing cos hyperbolic x by definition? E to the power x plus e to the power minus x by 2 you are writing, replace x by 5x so that you will get this, and 1 by 2 you can write outside. Now e to the power minus x into this you can write, this is you can, this is you can, okay, just you observe here. Now here you are getting e to the power 4x. Again the same e to the power m into e to the power n you can write as e to the power m plus n. Here you are writing e to the power minus x into e to the power 5x means minus x plus 5x you are getting here is equal to 4x. Similarly the second term you are getting here, and then here, okay. Now here yn, this is equal to y you are getting here. Yn means the nth derivative you have to find out. D to the power n of, that means nth derivative of y is equal to this you are writing here. 1 by 2 is a constant you are writing outside. Then d to the power n of the first one, d to the power 4x, d to the power n of the second one. Okay. Now already the same order taken in the previous problem you are applying the same. E to the power mx, the nth derivative is m to the power n in, m to the power n into e to the power mx you are writing. Here m is equal to 4, so that we are writing here 4 to the power n into e to the power 4x. Similarly, for the remaining thing, you can write here by taking f is equal to minus 6, you can write here this. Okay. Here, in solving this, you have to know the nth derivative. Already you are taking the previous class. We make this list of the formulas so that you can get the idea easily. Okay. Here, applying nth derivative of e to the power mx. You see, you are already taken in the previous classes. We refer that formulas. Okay. D to the power n e to the power mx is m to the power n into e to the power mx you are writing. Here also the same you are applying here. Okay. Now the next one. Okay. Here, find the nth derivative of log 9x square minus 4, and second one log 4 minus 4x plus x square, etc. that we have to solve here. Now here also in the same way, first you write here log of 9x square minus 4, that you take it as y. Y is equal to, you are taking some function, let y is equal to so and so. Now 9x square you can write as 3x whole square minus 4 you can write as 2 square. And already you know a square minus b square, how you can write a plus b into a minus b. Okay. We are writing the same thing as 3x plus 2 into 3x minus 2 under the log. Now log mn you can write as log m plus log n you can write. Or log ab you can write as log a plus log b, and the same you are writing here log 3x plus 2 plus log 3x minus 2. Now already you know the nth derivative of log ax plus b. The same you are applying here. Yn is equal to, you see here directly you don't know have the formula log of 9x square minus 4 is there, you don't have directly, that you are converting into log ax plus b, then you are applying log ax plus b and the derivative you are taking here. Now d to the power n of, you are writing this is now the nth derivative of log ax plus b. This is already you are taken in the previous classes, we refer that one. Okay, there you got here d to the power n log ax plus b equal to minus 1 to the power n minus 1 into n minus 1 factorial a to the power n by x plus b to the power n. Okay, you compare this, log 3x plus 2 is there, log ax plus b is there. Now a is equal to how much? A is equal to 3 and b is equal to how much? 2. And here a is equal to 3, b is equal to minus 2 you are getting here. Okay, so this formula you have to apply here. Okay, minus 1 to the power, what is the value of a here is only I will tell you for the first component. Okay, you see here only minus 1 to the power n minus 1, n minus 1 factor is same, and here a to the power n is there, here a is equal to, here 3 is there, 3 to the power n you are writing. Now in the denominator what you got here, ax plus b to the power n. What is ax plus b here? 3x plus 2 to the power n. Similarly the second one you are writing here. Okay, and now here you see minus 1 to the power n minus 1 into n minus 1 factorial is common. You can take from both the components and you can write the remaining thing. And then 3 to the power n is also common. You can write by taking common and you can add this. Okay, here itself you can stop. There is no need to simplify here. Okay. Now the next one. Here also the same way. Here log of 4 minus 4x plus x square is there. If you write rewrite this as log x square minus 4x plus 4. Now already you know a minus b whole square formula, that is equal to x minus 2 whole square equal to this bracketed quantity. Now the same you can add as log a to the power m, you can add as m log a, the same you are writing here, m log 2 log x minus 2 you are writing here. Okay, now again you see already this is y you are taking. Okay, now yn you have to take the nth derivative, you have to take it out. Already you refer that one in the previous problem you see there. This is the nth derivative of the log ax plus b, and here also you are getting the nth derivative of log ax with the same formula you have to apply. Here you see this is the formula you are applied for log ax plus b. Here also you can apply the same here, because 2 you can constant you can let outside, d to the power n of log ax minus 2. So log x minus 2 means ax plus b, you have to compare this with log ax plus b. A is equal to 1, b is equal to minus 2, and the same formula you are applying here, minus 1 to the power n minus 1, n minus 1 factorial into, here a is equal to how much? Ax plus b you have to compare with x minus 2 equal to ax plus b. A is equal to 1, b is equal to minus 2. Now a to the power n means we get here a is equal to 1 means 1 to the power n, and the denominator is ax plus b to the power n. We have to write what is ax plus b here. X minus 2 is the same ax plus b that we are writing as to the power n. And already you know 1 to the power n is how much? It is equal to 1. For anything to the power 1 to the power anything means you can get the value 1. Now the same you are writing here. Okay, that is the way you have to write here. Just you are writing this as x minus 2 whole square, then you are applying that you have to keep it in mind. Here square is you are getting here a minus b whole square formula, that's why you are writing that. Now the third one, okay, log 5x plus 1 into e to the power 3x plus 2. Again here you see log ab you can write as log a plus log b. Here if you take this as a and if you take this as b, then you can write log a plus log b. And already you know first one you write as it is, the second one log a to the power m you can write as m log a, that's why you're writing here 3x plus 2 log e. Already you know log e, the thing is there, if you not return 10 and then that is understood, that is to the base e you are writing here. That's why log e to the power log e base e is equal to 1 you are writing, that means this will become 1. Now that is 1 means we get log of 5x plus 1 plus 3x plus 2. Okay, now here you take the nth derivative. Now you got y. Okay, here you are not applying directly because you don't have the formula directly for this. That's why you are converting that into log ax plus b formula, and then you are taking here ax plus b, then you are applying that. Okay, now, first one is d to the power n means by applying the linearity property, you can write there d to the power n of log 5x plus 1 plus 3 into d to the power n of x. Just you have to apply the linearity property. Any number of components is 3, 4, 5, 6. Then you can apply in the same format. Here one component is there. Here two components are there. 3x plus 2 that you can write separately without bracket. You can write there. Now, how many components are? 1, 2, 3 components are there. You are applying d to the power n for 3 components one by one here, one by one. Now here the first one is log x plus b is format is there. That means you can apply the previous formula what are taken in the previous case. That is minus 1 to the power n minus 1 into n minus 1 factorial into a to the power n divided with x plus b to the power n. Now you see nth derivative of x is there. The first derivative will become 1. And then if you differentiate further, you get 0 because you have to get the nth derivative, not the single derivative. If you differentiate once you are getting 1, then again if you differentiate you get 0, and remaining thing anything you can take the nth derivative will also become 0 because the remaining thing get vanishes. Okay, remaining values get remaining higher derivative or get vanishes. Now here constant is there, that is equal to 0 you are writing because the first derivative itself is 0. D by dx of 2 is how much? That is equal to 0. There is no question of doing for the remaining thing, they will automatically become zeros. Okay, now here you got the first one only is existing, remaining two components get vanishing here. Now here log ax plus b means minus 1 to the power n minus 1 n minus 1 factorial. A is equal to 5 means a to the power n means 5 to the power n divided with ax plus b to the power n. Here you have to know the nth derivative of log ax plus b. Then only you can do this problem. Otherwise, it will be somewhat complicated. Okay, because you have to make the list of the formulas and you have to follow so that you can get the idea. Those who are attending newly, you can see the previous classes, what are taken in the previous classes. You refer that there you get the formula for all these things. Okay, there you are taken theorem and the problem with proof you are taken there. Okay, now the fourth one. Okay, now log of square root of x square plus 5x plus 6. Log here square root you can write as 1 to the here you can write to the power 1 by 2 you can write. Here the same you are written here, and then here x square plus 5x plus 3. If you factorize here, you get x plus 2 into x plus 3 and to the power 1 by 2. And again log a to the power m you can write as m log a. You are writing the same. And again log mn you can write as log m plus log n. Now you got this format. Okay. Now if you apply this is equal to y, you have to take the nth derivative. Nth derivative yn equal to d to the power n of you are writing. Again you have to apply the linearity property. Here two components are there. 1 by 2 is the constant you are writing outside, and the remaining is what? D to the power n of the first component and d to the power n of the second component. Again, you see here you are getting only log x plus b format you are getting. Again, the same formula you have to apply here. You see what is the formula? You see the previous class what you have taken here somewhere in the starting you have taken. This is the formula you got here. The same you have to know. Then you have to compare and you have to write. Now here you see what is the value of a here? Ax plus b means a is equal to 1, b is equal to 2. You see here are getting minus 1 to the power n minus 1, n minus 1 factorial. A to the power n is there, a is equal to 1, 1 to the power n, and ax plus b to the power n you are writing. Now similarly here a is equal to 1, b is equal to 3. That's why you are writing the same manner. Minus 1 to the power n minus 1, n minus 1 factorial. A is equal to 1 means 1 to the power n divided with x plus 3 to the power n. Now already you know 1 to the power n means you can write that is equal to 1 because 1 to the power anything will become the same. 1 to the power n is there, that will become 1. Now, now the same here. If you want, you can write one more step here. If you want, you can write one more step here. How means you see here you can take minus 1 to the power n minus 1 factorial as common, and you can write the remaining thing by taking that as common, or you can put as it is, no problem here, because you can take here because 1 to the power n is 1, and also 1 you are getting. You can write minus 1 to the power n minus 1 to n minus 1 factorial as common, and you can write the remaining thing as it is. Okay, you can put the remaining as it is. Okay. Now the next one, y equal to log 10 log 2x plus 3 to the power 4 3 minus 2x to the power 5 to the base 10 is there. Here base is 10 is there. Now already know one of the property, log a to the base b you can write as log a by log b. Okay. By using that one here you can write log 2x plus 3 to the power 4 3 minus 2x to the power 5 divided with log 10 you can write. Okay, log 10 you can write. Now 1 by log 10 of, again here you see you are getting here first you see log mn you apply here. Log mn means log m plus log n you can get. Again log, for that you take log a to the power m you can write as m log a. By taking that one here, first you apply log mn equal to log m plus log n, and then you apply log a to the power m equal to m log a, so that you will get this. Now yn equal to 1 by log 10, 1 by log 10, 4 into, again the same linearity property you have to apply here. Okay. Now d to the power n of you are getting this, and plus 5 into d to the power n of y component, second component you are writing here. Okay. Again you see this is of the format. Of course all the formats here are getting to the log x plus b format you are getting here. Okay. Now 1 by log 10 into 4 into minus 1 to the power n minus 1 n minus 1 factorial 2 to, because you see we have to compare this with log ax plus b. 2x plus 3 we have to compare with x plus b. A is equal to 2 and b is equal to 3. Okay. So that what is the value of a here? A is equal to 2. In the formula here we have a to the power n is there. We are replacing that a by 2, and here 2x plus 3, bx plus b to the power n you are writing. Now 5 into, again here also this is same. Okay, here minus 1 to the power n minus 1 n minus 1 factorial. What is the value of a here? A is equal to minus 2 is there. Okay, don't get confused here. You cannot ax plus b or b plus ax also you cannot. Both are one and same. But here the value is equal to minus 2 you are getting here. That's why you are writing minus 2 to the power n divided with x plus b to the power n you are writing. Now again, that's I'm already told to you. Here you see you can take this as common. Minus 1 to the power n minus 1 into n minus 1 factorial. 2 to the power n you can take it as common. And here if you take 2 to the power n as common, you get here 2 minus 2 you can write as minus 1 into 2 you can write. And so that you get here minus 1 to the power n into 2 to the power n. That's why here writing 5 into minus 1 to the power n divided with 3 minus 2 x to the power n, and this will become the same. Here you are writing the same you are writing here. This you are taking as common, remaining is this you are getting. Okay, there is no problem here. But here you remember minus 2 to the power n means you have to write minus 1 into 2 you have to write. Then you have to take the power minus 1 to the power n into 2 to the power n, you get 2 to the power n is already taken outside, that the remaining you have to write here. Now the next one. Okay, here also logarithmic function is there. Here also you write log y is equal to log 7x plus 6 to the power 3 divided with x minus 1 to the power 7 with the square root along with the base 10 is there. Okay, again the same format, log a to the base b you can write as log a by log b. The same you are adding here in the just like in the previous case also you are writing the same way. First if power here nothing is there, there is no problem, but here power 10 is there, base 10 is there, that's why you have to write log ab, you can log a to the base b you can write as log a by log b. The same you are adding here, 1 by log 10, 1 by log 10, log of this you are writing. Now this square root you can write as power 1 by 2. Again, you know log a to the power m, how you can write m log a. The same you are it is there, you are writing the same format. Now you apply log m by n is there. Log m by n, how you can write log m minus log n. Again log m, the first component will become power 3 is there here. Again log a to the power m will become m log a. The same you are writing here. The first component is you are writing here minus of the second component you are writing here. Okay. Now this is equal to y. Again, you see here you are getting log ax plus b format. You are getting here. Okay. So now yn equal to 1 by 2 log 10. Okay. Here 2 is there. Here 2 log 10 is there. You are writing the same. 3 into again after the linearity property. 3 into d to the power n log 7x plus 6 minus here 7 d to the power n d to the power n log x minus 1 is there. Okay. Now 1 by 2 log 10, 1 by 2 log 10. Okay, that's your writing. Now 3, that 3 you are writing as it is. Again log ax plus b, how you can write? Minus 1 to the power n minus 1 into n minus 1 factorial into a to the power n by x plus b to the power n. Here ax plus b means 7x plus 6 to the power n, and a is equal to how much? Ax plus b means here we'll get here log x plus b means a is equal to 7. By comparing you are adding a 7 to the power n. Here also you are adding the same format. Here a is equal to 1, b is equal to minus 1. Okay, that's why you are writing here a is equal to 1, b is equal to minus 1 you are writing. Okay, x minus 1 to the power n you are writing here. A to the power n means you are getting 1 to the power n. 1 to the power n means that is equal to 1, and the remaining is same. Here you see you are taking minus 1 to the power n minus 1 into n minus 1 factor as common, and already 2 log 10 is there in the denominator, that you can take it as common. Now the remaining is here 3 into 7 to the power n by the remaining, and here also 1 to the power n is 1. Already we have taken minus 1 to the power n minus 1 into n minus 1 factor as common. The remaining here 7 by x minus 1 to the power n. Okay. Hello. Now find the nth derivative of sine square x plus 3 cos square 5x. Here find the nth derivative of sine square x plus 3 cos square 5. Here also here uh, here you see sine square x means you have the formula for sine bx plus b or sine ax plus b is the formula is there. But here sine square means for the product you don't have the formula, you don't apply directly the linearity property. Okay, you can apply, but here you have to split it. Okay. Now you write sine square x as 1 minus cos 2x by 2, plus cos square 5x you can write as 1 plus cos 2x by 2 you are writing here. Because sine square a is equal to 1 minus cos 2a by 2, cos square a equal to 1 plus cos 2a by 2 you are writing, and here equal to 1 by 2, 1 minus cos 2. You see here 1 by 2 is there, here also 1 by 2 is there. You can take 1 by 2 as common, and here what is the remaining here? The remaining is you have to multiply here. 1 minus cos 2x into 1 plus cos 10x is there. You have to multiply and you have to simplify, so that here we get here 4 components you are getting. If you simplify further, you are getting here this you are getting. Now this is equal to y. You have to find out yn. You have to find out yn. Now you apply the linearity property. D to the power n4. What will it will become? What is the value here? You see 4 is a constant. If you differentiate with respect to x, you will get 0. First derivative itself is 0, means remaining thing, the second derivative, third, fourth, etc. whatever may be, that will get vanishes, will get as equal to 0. Now here you see d to the power n cos 2x is there. You see in all the previous cases you got log ax plus b is there. Okay, but here you are getting cos 2x you are getting. Okay, cos 2x, that is here you have to apply. Already you know the formula for cos x plus b or cos bx plus c. The same you can apply here. Here also cos 10x is there, nth derivative of cos 10x also we can apply. Because the what is the nth derivative of cos ax? Here a to the power n cos n pi by 2 plus ax plus b you can write. You see here, you see the previous classes, they were already taken the nth derivative of cos ax plus b is equal to a to the power n cos n pi by 2 plus ax plus b you are taken. Or a plus b or bx plus c, whatever it may be, just n pi by 2 plus of that function that we are getting here. Okay. Now here also in the same way, here cos ax means a is equal to 2 you are getting. That's why you are adding here a to the power n cos n pi by 2 plus that function you are adding. Here also 10 to the power n, because cos ax plus b means a is equal to 10, b equal to 0. Of course, if you want, you can substitute and you can verify that. Okay, you can verify that. Now 3 into 10 to the power n cos n pi by 2 plus 10x you are getting 1 by 2, 1 by 2, 3 into 10 to the power n, and here remaining is same. Okay, there is no need to write here, the same you are writing here, that is this is you are writing one, then you are writing this is the next. And here, okay, here itself I will start.